Hello and welcome to advanced session 3 of the PhysiCell Hackathon and workshop from 2023, and in general our training materials for this year. And in this session, I'm going to be discussing PhysiCell coloring functions. In terms of an agenda, goals, and links, we're going to go over the built-in SVG visualization in PhysiCell, demonstrate the default cell coloring function from a template project, explore, if you will, on the fly coloring in PhysiCell Studio, and create our own custom coloring function within PhysiCell source code, with our learning goal of being the ability to create a custom cell coloring function. And I'll include in this slide deck a link to the code, as well as a link to the video. So the default PhysiCell visualization is in the form of SVGs. SVGs, what are SVGs? It stands for Scalable Vector Graphics. It can make really well-defined, as in high definition graphics, and it's an XML-based image format. So here's an example of an SVG output from PhysiCell. In particular, it's graphic, and it contains cells, their size, their location in the domain, and they have a color associated with them. And then here is a snippet of the XML that was used to generate this as part of this SVG, and that SVG was eventually, that XML was eventually interpreted, read, and then rendered into this graphic. SVGs are output by default by PhysiCell. If you were to want to change that within the studio, you could navigate to this checkbox and turn it off, but all of our sample projects end up with this circuit on. The SVG output function generates visual output of the cell positions, as already mentioned, and other simulation metadata, such as the timestamp of the output. And it also creates a legend with cell names and their color. Now, what we're really focusing on and thinking about here is how we will kind of modify the cell color. There's a couple main ways to do that, and I'll discuss a couple more as well. So there are some pre-built options, and we can make custom ones. Overall, why are we doing this? Well, we can use cell coloring to identify cell properties. We can color by type. We can color by phase and cell cycle, color by pressure. Basically, any variable that's continuous, categorical, anything that's associated with an agent, we can use to color. So it can give us a lot of valuable visual information on what's going on in the simulation. And there's 2+ flavors. There are some pre-built options. You can make your own. I've seen a lot of success with using some pre-built options and then tweaking them. And then for on-the-fly visualization that you just might want to be exploring, what coloring will help you understand the simulation the best, you might choose to use the studio. In terms of pre-built coloring functions, the function definitions, signatures and definitions are all located in PhysiCell pathology. And that contains a number of pre-built functions. You might see these as you go through the sample projects. You might see these used in various sample projects. And so in particular, in one sample project, in the template project, that uses the paint by number cell coloring function. And that's what I'd like to highlight here. The function take. So this is straight out of the PhysiCell source code, out of the previous file, the pathology, PhysiCell pathology.cpp. It returns a vector of strings, and it takes a pointer to a cell agent. And this is going to give the function access to all the cell properties. This is somewhat unique to this particular function, but well, the important thing here is that we're actually going to end up in this particular function, you end up generating a set of options for colors. because the SVG standard enables you to use RGB as well as string names and other. The standard includes multiple ways of calling out a color, and I'll have a link at the end that is a link to the standard, so you can look at that more if it's appropriate. For the purposes of right now, please take it on my word that you can indeed use string names to call out colors in the SVG standard. So we generate this vector of strings. It ends up having 13 elements. And then we initialize another vector called output. Now, output is it's the real, what ends up getting used to generate our cell colors. In this function, we're starting with everything as black, and then we end up modifying that based on cell type. So the function finds the cell type and then pulls out of this vector of strings a color based on the number of the cell definition. So basically what that means is whatever the first cell definition is going to be gray. Whatever the second one that was defined was, it's going to be red in the SVG, and so on. And that's kind of, so this function then will return output, and output gets used eventually to generate that XML calling out those colors. So there are 4 colors in output. That's 1 each for the cytoplasm border, nucleus, and the nucleus border. If you'd like more information on this, you can look at PhysiCell pathology and PhysiCell SVG. So let's demo the results of this paint by number. So you can run the commands below in PhysiCell and a PhysiCell folder to start the studio with a template project. So I'm going to accept. So I already have this is the case. I've kind of already gotten this going. So make template, and what's not included there is make. Now we'll compile the template project. Great. So now I have the template project made. And I'm going to run the studio, which I actually have on my computer open. Close that and get that started. Just make sure you use your own path to studio.py. In my case, I have the whole thing alias to studio. Actually, let me clear that. And things are running the way that I hope them to be running. If I just simply run, I will get gray cells. I'm going to let this run out to just a day. That. Let's see what I have. Great, gray cells. And almost 1 day. Great, 1 day. And that was output every hour, so great. And I see 10 gray cells, and this matches what's in the slides. Now to look at the paint by number feature, we're going to need to add another type. So I'm going to go to cell types tab and click copy. And I'm going to change the name to default copy and rerun the simulation. Copy. Great. Now I can just rerun. And because we're running this by number coloring function, basically I don't have to do anything. It's already coloring those second cell type red. Great. So we've got gray ones in the same positions as before, and now we also have additional red ones. This is expected behavior for the template project. We're at 24 hours, so I'll just go to 4. And they've divided, and both cell types are dividing, they're dividing at the same rate. It's just direct copy. Everything is as expected. And if I were to add another type, then it would end up being, we could simulate it if we wanted to, but it would end up being yellow. And then a fourth type, it would be green. And if I was to delete one of those types, it would, what was once green would become yellow. Anyway, great. And so our simulation matched the results here, and the coloring in this case is based on the categorical variable type. And we're getting what's expected. Red is after gray. You can also use the studio. So now another way to look at coloring, and this is not as permanent as outputting an SVG, but it can be very interesting for exploring your simulation outputs and thinking through what is a good way to color an agent in an SVG output. So I like to use this video for quick visualization. You can use it for everything that I've already talked about for coloring an SVG and motility, direction, pressure, and many other properties. So if you click on the .map button, then you'll get a range of cell properties that you can color by, again, that are both categorical and tenuous. So let's just take a quick look. Looks like in my demo, I colored by phase. So .map, full list, and current phase. Great. So we see a range of phases. You'd have to refer back to the specific cycle model to know what number was what phase. But we can see that there's a range of phases. And now we're no longer coloring by type also, which is interesting. So this was gray, I believe, and this was red. And so it's just, again, you're seeing, now we're doing a different category. We can do some continuous ones one in here. I don't think that it's not going to be very meaningful here because they're all going to be uniform. Here's something, okay, migration bias direction. These cells are non-motile, so I expect the X migration bias direction to be 0, and that's what I'm seeing. You can see here that you can get a range though. The studio defaults to some color maps. You could do the same kind of thing also in SVG. You can make your own color map, and we're going to get into that a little bit in the custom coloring function, how that might start to look. Great. So let's get started with our custom coloring function. To do this, we'll go into the C++. So in your favorite editor, whatever works for you, find custom.h and be able to copy paste out of this PDF. So basically we need to declare our custom coloring function, give it a signature. Great. And then we can get most of the work will be in the regular source code file. I have that pulled up here. I've got my function shell. I'm just putting it at the end of the file. And these are kind of like some extra instructions that can help us along. You wouldn't need to do this, but this is basically our goals are how we're going to do this. And then this is a reminder of what the different numbers what the places in the output vector mean. So for the custom coloring function, we're going to start with color by number, which funnily enough, I just demoed. So I'll get this is kind of, so what I'm showing here is that hybrid way of doing it. All right, I just selected that line. Great. Now, interestingly, dead cells are already going to be black. I didn't show you this, but at the end of this, after you go through all the colors for live cells, there's this function tests for dead cells and turns if they're apoptotic, turns them black, and if they're necrotic, turns them brown. So I'm not going to actually, this is already baked in up here, so I don't need to do that in my custom code. But I am going to shade the live cells by proliferation rate. And this is the whole thing. I'll step by it. I'll step through it piece by piece, actually probably in the code editor. Great, I'll try to fix that. But great, now it looks a little bit better. This line, first we take our cell pointer, and in this case, we're actually going to only color, the way this is set up, we'll color by only the default cells. This won't cover all cells, so we'll be able to see that. And if they're dead, we leave them alone and just take whatever came out of our paint by number coloring function. But if they are alive and they're a default cell type, then we're going to get their current cell cycle entry rate and divide it by their default or their initial defined cell cycle entry rate, and use that to calculate a number S. And then basically we use that to color. This is a little bit of housekeeping to make sure we don't overshoot. In this case, we're going to use an RGB type coloring scheme, whereas before, and the paint by numbers, it uses a string. You can use RGB values also. So that's what's being utilized here. So our values are going to, the R, G, and B channels range from 0 to 255. So we take a continuous variable, a continuous cell property, and we basically try to get it between 0 and 255. That's what we have going on here. And that gives us our color. This color ends up being used to generate the values for our output vector. So we can see here that the cytoplasm will end up being whatever basically everything except for the outside border, which will remain black, is going to get colored by cell cycle entry. So the cytoplasm, the nuclear fill, and the nuclear outline. All right, great. Let's see. Now let's check where we're at. And then that'll return output. The final step is we have to tell in main Let's tell it to look for our custom coloring function. Comment that one out, put in the one, custom one, all right, that's saved. And I think, yep, then we run make. And on. Well, again, I just saw this bug. I had originally had it said dead. Of course, we actually need to get into phenotype and then check to see if it's dead. So hopefully this will work as expected, and we'll be coloring the default cells only if dead is false. And this should make great. Now, and I'll update the slides as well. We'll rerun the simulation. So remember, these were gray, and now they're yellow, which is as expected. We're at 24 hours more. Great. Going back to here. Great. One more second, please. Great. Here's the slide that I actually had updated. And after running make and rerunning the simulation, we see yellow cells for the default cell type. In this case, I had deleted the second cell type, so that's why we don't see any red cells. What we have going on here for RGB is that we're ending up with our default cell type as 255, 255, and 0, which is yellow. So all these cells have the cell cycle that are at their base level. They're basically what we're showing here is that this coloring is showing that the cell cycle entry rate hasn't changed from the original definition. That's all coming from the code back in here. So basically, we S is equal to 1, which ends up making color equal to 255. And so what we end up putting in for the faux colors and the border, except for the external border, is 255, 255, 255 minus 255 or 0. And that gives us yellow. Great. And so in terms of final notes, let's go over what covered. There are pre-built coloring functions available in PhysiCell biology.cpp. The default coloring function in the template is a paint by type of function, so it colors cells by type. And there are others available that might color by cell cycle phase, for example. You can explore attributes to color with in the studio. And custom coloring functions can be made that can color by any cell attribute, similar to the studio, except they'll be in the hard output of the SVG. You can then use some other tools to work with and manipulate, such as making a GIF or a JPEG from an MP4 from an MP4 from. You can color both the cytoplasm and the nucleus. For example, you can color by both type and the cell cycle entry rate. And that's left to the excited viewer, as noted here, as noted before. If I had just colored everything and not done this, if I colored everything that was alive, then I wouldn't know which cells had a change in their cell cycle entry rate by type. And then finally, here's the promised link. I'm sorry about that. Here's the promised link to the W3C standards for SVG files. Great. And here's our typical acknowledgement slide. I hope everybody has who views this has gained what they need to from it. Thanks.